And if you want to go for research, if you want to be a researcher, data scientist, big data scientist, or AI researcher, take this a little more theoretical thing. But keep in mind there are less jobs for researchers and big data or data scientists. Alright, there are way less jobs for these guys, and you need to have at least a master's or PhD. So it takes more investment in time and energy to be like this, but demand is less. Computer vision, researcher, all these are a little bit more research oriented. So all of these are third level and fourth level and fifth level. Like some of them are grad school level, like information retrieval and web research. This is definitely for graduate student level. Distributed systems are usually a fourth year level class. Compiler design is also fourth year, pretty complex and complicated. Artificial computer vision as well, this is fourth year. So lastly, what I want to do is take you through so what I wanted to do. Hold on, let me close the door. So last thing that I want to show you, so you now understand differences among the three: computer science, software engineering. So I was thinking about big data. I want to show you SFU's master's degree program, SFU Big Data. So they now opened up a master's program in big data, which is gonna equip you with a bunch of skills to be big data scientists and researchers. So you can work at big companies like Google, Facebook. They all require big data scientists to analyze big data and then make something out of the data. And that's a little bit more in the research level. So you can go to professional master's degree in big data, which is really practical. This is really practical. It's not theoretical. There are also other masters in SFU, more theory-based masters, graduate computer science, but big data is really practical. Whereas this this could be really theoretical. But anyways, why big data? Big data transfers massive amount of information. So Facebook, Twitter, YouTube, they all require data scientists, and that's a little more theoretical though. What do you study? It's super deeper theoretical, and I can't even understand. I don't think I have a confidence. Even if I got 3.56 GPA from undergrad, that this stuff like big data and masters was like beyond my understanding. I looked through some of the programs, and the super high complex big data, map reduce, distributed database, distributed computing. It's pretty complicated algorithm analysis, scalability, distributed computing, cloud computing. So quite a bit of but this requires you to take a corp. That's why I see SFE is really practical and get your job, because this requires you to take at least one semester of internship, which is why you can so machine learning is so hard. I didn't take it, but it's definitely master's level course. So hard because it requires math, linear algebra, and computer science. It's a tough course. Algorithm is tough as well. Data mining, tough. Everything you need to be really good at studying to be like this. So that's more practical, but what you study there is pretty theoretical. But they teach you some practical stuff, like a little bit of programming assignments in these classes to enable you to have actual programming skills with some theoretical stuff. Alright? So same thing in UBC, computer engineering and science. Let's take a quick look at it. Computer engineering or computer science, they have two streams, computer science and computer engineering. Computer science studies theoretical financial information. Computer engineering integrates both electrical engineering, a little bit of hardware and circuits, hardware, and software aspect, right? So you need to go through that, but I didn't want to go to UBC because they required me to study physics. This is a chipset, like an embedded system. I didn't want to deal with anything like electric circuit or hardware, so I didn't take computer engineering. Like you take this and then you open up, probably course description, digital system design. So probably, hardware, computer engineering, electric system design. But that's it, guys. That's how you can do research like I did, and then kind of get to know. And then lastly, I want to show you job demand, software engineer versus, let's say, data science. Software engineer has way more demand, which is data science. Should I become data science? See, you can look up people have same questions. Should I become a data scientist or software engineer? Data science requires you to have a master's degree at least. Data science is being called as sexiest job 20. Anyways, when you concentrate. Okay. But anyways, there are lots of demands for data scientists because big data, YouTube, Google, Facebook, Twitter, it's expanding. See, big shorts like in Google, Amazon, Facebook, LinkedIn, they all need to deal with big amount of data, so they require big data scientists. Long-term growth with software engineers here for a long time. It'll be here for a long time. Data analysis and data science will likely merge and create new specialized roles. Salary depends where you are, so you can look up all this. Software engineer are hardcore computer programmers who live their lives running lines of code. Data science, relatively new role, coined by data junks, analyst, computer programming, computer science. Salary, long-term growth. They're gonna be both good, but it requires you to have master's degree to be at least data scientist. Data modeling, machine learning, algorithm. That's data science, graduate level. Job opportunity, you can look up this, by yourself. This software engineer, C#, these are programming languages, .NET, PHP, CSS. Data engineer, data scientist requires more abstract, conceptual things like data mining, machine learning, research analytics, algorithm. These are all stuff that I talked about in computer science. These are more, hardcore, quite complex stuff, and you really need to be smart to do this. You need to be at least having master's or PhD. So yeah, and it's not fun to study at master's or PhD level in computer science. It's just so abstract. All right. Anyways, that's it, guys. Hope you got lots of value from this, and if you have any questions, do your own research and then establish your own hypothesis, and then if you don't still get answer, ask me questions, but give me some hypothesis, some questions, some assumptions. That'll be better for you. Anyways, thank you guys for watching. Questions are always welcome, but ask me smart questions. All right, see you guys. Bye bye.